What's up, math enthusiasts and students? This is Math Academy. I'm Joshua Lingasan.
I'm Jane Erbakan. I'm Katrina Martinez. And I'm Delia Korean. Today's video, we will be talking about antiderivatives or integrals.
So now, what are antiderivatives? Well, they're actually inverses or opposites of derivatives. Oftentimes, we can also refer to them as integrals. They're one of the fundamental theorems of calculus. The process of finding all integrals is called integration, also known as antidifferentiation.
There are two types of antiderivatives, indefinite and definite integrals. Here are the notations. For indefinite integrals, the notation is the integral of f of x dx, while indefinite is the integral of a to b fx dx. As you can see, both are integrals as they contain the integral sign. To differentiate the two integrals, indefinite integrals has no limits or bounds, and it represents a family of functions whose derivatives are f. While for definite integrals, it has limits or bounds, and it represents a number when the limits are constants. Special thing about integrals, it always has c or arbitrary constant.
This is a notation and formula of an indefinite integral. Now, let's label all the parts of this notation because it seems very long. First, we have this sign over here. This sign is called the integral sign. Next, we have this f of x over here. This f of x is called the integral. Again, the integral. Next off, we will be naming both of these with dx. This is called the differential. The differential. Within the differential, we have this x. This x, this one x over in here, this dx, is called the variable of integration. Variable of integration. Now, we have one very interesting part about indefinite integrals. It always has an arbitrary constant, or this c over here. This c over here is called arbitrary constant. Arbitrary constant. Last but not least, we have f prime of x equals fx. This is the condition. So to recapitulate everything, this is the notation of the indefinite integral. Within the indefinite integral, we have the integral sign, then we have the integral. We also have the differential, and we have the x, which is the variable of integration, and we have the arbitrary constant, which is the c, and the condition.
The first rule we have is the constant rule. This is the formula for the constant rule. We have two examples here, and we're gonna solve them. The first example, the integral of 5 dx. Now, we're gonna use this formula, kx dx plus c. First, we're gonna copy the constant, multiply x plus c, and then you simplify it. It's that easy. Okay, for the second example, we're gonna do the same. Negative 7 times x plus c. And then we simplify it. Negative 7x plus c.
Second rule is the power rule. The formula for the power rule is the integral of x to the power of n dx is equal to x raised to the power of n plus 1 over n plus 1, where n is not equal to negative 1 and n is an element of q. Where f of x is equals to 5x raised to the power of 4 is f of s is equals to 1 over 4 plus 1 x raised to the power of 4 plus 1 plus c is equals to 1 over 5 x 5 plus c, or x of 5 is over 5 plus c. There you have the final answer. For example number 2, we're going to do a shortcut. Gx equals to 2x cubed is equal to, copy the constant 2, x 3 add 1 over 3 plus 1 equals to 2x 3 plus 1 4 3 plus 1 4 plus c, and that's your final answer.
The third rule is the power rule of x with the power of negative 1. And here is the formula. The integral of x with the power of negative 1 dx equals ln x plus c. Always remember, the integral of x by the negative 1 is equal to ln x, or natural logarithm. Also, if we use the normal power rule, our answers will be undefined. Here we have two examples. First, we copy 10, and then using the power rule of x by the power of negative 1, ln x plus c. We also do the same to the example number 2. Copy and put ln x plus c.
The fourth rule is constant multiple rule. The formula is the integral of ku dx is equal to k multiplied to the integral of u dx. So we have two examples. The first example is the integral of 3x squared dx. The first statement we're going to do is we're going to isolate 3, the constant, and multiply it to the integral of x squared. So 3 times the integral of x squared dx. And then we can apply the power rule. So 3 times x to the power of 2 plus 1, and copy what's at the top. 2 plus 1 plus c. Now, we're gonna do is 3x cubed over 3 plus c. As you can see, it is cancelable. So we're gonna cancel 3 and 3. 3 becomes 1, 3 becomes 1. When you multiply 1 to x cubed, it will become x cubed. So the final answer is x cubed plus c. For example number 2, we're gonna do the same thing we did for example number 1. So first thing that we're gonna do is isolate number 4, which is the constant, and multiply it to the integral of x cubed. So 4 times x cubed dx. Next is 4 times x, 3 plus 1, copy, 3 plus 1 plus c. 4 x to the power of 4 over 4 plus c. Since it's also cancelable, we're gonna cancel 4 and 4 is 1, 1. 1 times x to the power of 4 is x to the power of 4 plus c. This is our final answer.
Sum and difference rule. So the sum and difference rule is basically finding all the integrals of each term and adding and minusing them all together. So the formula of this rule is the integral of the quantity of u plus or minus v dx equals the integral of u dx plus minus the integral of v dx. So we have two examples over here. Let's try to solve it. First, we have example number 1, which is the integral of 6x x squared minus 2x minus 1 dx. So the first thing that we do is times each term to the x. So let's do that. Then we focus on all the x's, and we also isolate the constants away from the x's. So to do that, we put here first 6 and then x. And remember that in integration it's always plus 1. So 2 plus 1 is 3, so x cubed. And then the number that we put here will be also the number of the denominator. Next, we'll do 2, so minus 2. And we have x, so x, there's an imaginary 1 plus 1, this becomes squared. We copy 2 in the bottom, and then minus the next term is negative 1. Here, we should always remember that 1 is always equal to x. So here that it's negative 1, this is equal to negative x. And then, plus c. Now we can simplify these terms. We have 3 and x. We can both divide this by 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. So this is now equal to 2x cubed minus. This one can also be simplified because it's negative 2. So negative 2, you can belong to negative 1, and this one is cancelled. So this is basically, this is invisible, x squared. And then we copy negative x, and copy c. So the final answer in the integral of this is 2x cubed minus x squared minus x plus c. This is our second example. It says the integral of 9x squared plus 7 minus 5x cubed dx. So we can do a shortcut. We just have to isolate the numericals first and then focus on the x later. So we do 9 and then x plus 1 of the power, so that's 2 over 3 plus 7. And then we can just immediately put an x because any constant, the integral is a constant of nx, so 7x. And we do 5. We copy 5, negative 5, and then we plus 1 on x cubed. So this becomes 4, this becomes 4, plus c. Now we can see that we can simplify some numbers here because 9 will be divided by 3 times. So this becomes 3, this becomes cancelled. And on this one, we don't have to simplify this, and this one, we can just put them all together. The final answer will be 3x cubed plus 7x minus 5x to the power of 4 over 4c. And this is your final answer.
Applications of calculus in engineering. So, an architect engineer uses integration in determining the necessary materials to construct curve-shaped constructions such as a dome or a sports area. They also use this to measure the weight of that structure. Furthermore, calculus is used to improve architecture of important infrastructures as buildings.
In electrical engineering, calculus is used to determine the exact length of power cable needed to connect two substations which are miles away from each other.
Spaceflight engineers frequently use calculus when planning for long missions. To launch an exploratory probe, they must consider the different orbiting velocities of the Earth and the planet the probe is targeted for, as well as other gravitational influences like the Sun and the Moon.
Application of calculus in physics. In physics, integration and derivatives are very much needed. For example, to calculate the center of mass, center of gravity, and mass moment of inertia of a sports utility vehicle. Furthermore, to calculate the velocity and trajectory of an object, predict the positions of planets, and understand electromagnetism, calculus is also used.
Application of calculus in finance. Credit card companies use calculus to set the minimum payments due on credit card statements. At the same time, the statements is processed by considering multiple variables such as changing interest rates and a fluctuating available balance.
And there we have it, our calculus
I'm a derivative.
episode. I hope you learned a lot from us. Don't forget to like,
Subscribe.